In this episode, I want to talk about a part of the renewable projects that's often treated as a minor technical details. When it goes wrong, the consequences are commercial, not technical. That part is SCADA, and it's one of the biggest blind spots in the industry. So first of all, what is SCADA? SCADA stands for Supervisory Control and Data Acquisition. And it's put into simple terms, that is a central nerve system that's connecting to all your project's assets, machineries, network switches, variable speed drives, computers, and anything that you can think of that is a piece of electronics inside. Has potential to connect to the local SCADA system. We do quite often speak to the project EPCs and the project developers from time to time, and quite often people raise the questions to us and say, is there anything else is there any other potentially bigger services we can provide? And the answer is yes, we can also help our EPC clients and developers to understand more about the SCADA, because that's the central nerve systems, and it's quite often, and it's the cost for the SCADA is usually 1 to 2% of the entire project. So it's very easy to be ignored from the start. So very often that is the problems are hidden from the design phase, and is until the FAT and the commissioning on site, the problem will surface. And it's too late because the damage will already been caused, and the project's already suffered delay and rework, and sometimes even cease of the contract or the cancellation of the energy purchase agreements. And all of this can be resolved can be a result of SCADA technical issues. But because of the criticality of the SCADA systems, we do suggest that it to be treated as early as possible and with enough seriousness. And from that, we can stop in a lot of catastrophic failure to your systems, to your projects. SCADA has been treated as a commodity by many people, especially the large EPC, the project EPCs. Only because of taking such lower value of the entire project, it doesn't mean that it's not a critical component. As a matter of fact, it is the most critical components of your renewable energy projects, because it's taken such a wider responsibility to interconnect with all your site equipments, systems, and make sure the assurance on the interoperability and the working together, bring everything's working together and orchestrate entire site operational performance. It is a very big responsibility, and that is carried out by your SCADA systems. Okay, there's quite often due to the SCADA, and one of the common issue that we have observed from numerous solar farms, battery plants, and wind farms, that is to do with communications. The communications has different layers. The first layer is the site equipment layers communication. The second layer is the site network communication. The third layer is the communication to the network service providers, transmission network providers, or distribution network service providers. And from that point onwards, it reports data to AEMO. The small technical issue can carry outsized commercial risks. Small technical issues like communication failures and intermittent communication can cause those commercial risks, such as we mentioned before, the energy stop of energy trading, or under optimized energy output, or the energy generation of your plant. There could be other technical issues like the energy management software is not performing, is not functioning to is not optimized to regulating the energy input and output between each various generation systems, solar panels, battery plants, and the wind farms and the diesel generators. If some of the sites hybrid system, they still have diesel generators there. So it relies on the central EMS systems to regulate energy flows and controlling the voltage, current, and the frequencies, and to coordinate and orchestrate how the site energy has been generated and absorbed and stored by each component. For the renewable energy projects, it is often fall quietly and not catastrophically, which means that when it fails, it takes time to fail. It's not going to be, people were not going to realize it in the first instance. But when it fails, the commercial implication will be noticed straight away, which including the energy trading stops, or the less revenue can be generated from your renewable energy plants, or simply because your systems cannot pass the R2 tests, cannot reach the 100% of the designed generation output. When SCADA is under-engineered or fragmented, operators lost the visibility and control. And consequently, as the project owner, you would potentially lose revenue and cause more money to bring people to site to troubleshoot fixing issues. Because of it's the central nervous systems. If the SCADA failed, the whole plans will potentially can fail as well. So it's very important to make sure we iron out all of these issues at early stage of your projects. Ideally, we want to engage with our customer at the development phase, as a preliminary design phase. We can help you to formulate a preliminary design. As a part of that, we will provide a solution architecture, that is laid out for your local solar renewable energy plants. And based on that, we can also help you to formulate a budget for the SCADA and the surrounding facilities. Problems emerge during commissioning or operations when changes are expensive. So you don't want to you want to minimize all the design changes or the rework during the site commissioning stage, or even in the operation, because those changes can be very expensive. And some of them are not even fundamentally fixing your SCADA problems, because the SCADA needs to have a solid design and a foundation. And based on that, and we'll set a system up as well. If it's not on a solid foundation, for example, if the project has chosen at early stage choosing the wrong SCADA platform or the hardware, it's virtually impossible to change the whole thing ground up during the commissioning, in the commissioning stage or in the operation stage, because that would mean we're going to throw everything out the window and build everything from ground up and change all the auxiliary devices as well, which just means that you virtually has to redo your project over again. So that's not really possible, and the only way to fixing the problem is to put a band-aid solution. That means after a few years band-aid on top of the band-aid, the system will become even more fragmented, and it's not ready. And it'll be certain make it even more challenge to integrate those fragmented data into your data warehouse for the data analytics, which means that you are probably going to be a bit less efficient to integrate your system into an AI-driven data warehouse. With AI-driven data warehouse, it will make your data analysis even more efficient. Okay, so problems emerges always during the commissioning and the site stage. So I have seen some of the projects, I have witnessed some of the projects has been already in the delivery phase, construction and commissioning phase on the project on site, and then all of a sudden problem occurs, and the with the intermittent communication, they have to do an extensive troubleshooting. With the communication that delay the entire project schedule. So bring the R1 and R2 testing to a halt, and because they have to fix the problem, so that delay the project month and month. It's like you're driving a vehicle that's you got a small area of a blind spot, but it can cause a major incidents for any vehicle drivers. The SCADA being a drop in the ocean, you would ignore it, and you think everybody will be able to do the job for you. But as a matter of fact, it turns out not necessarily the case for many projects. And quite often there's a band-aid solution applied to get over the issue temporarily, whereas the issue needs to be fundamentally resolved. And our site is not the best revenue for doing that. The best place to have a fundamental fix is early on. It's the early stage of your projects where there's design, the preliminary design stage, or even before. Outcomes are locked in early through system level thinking. Projects behave differently when SCADA is engineered deliberately. Each project is different. Despite of the nature of the project look the same. For example, the battery energy management system, and each project do have a different components, different protection relays, different electrical systems, different substation room built, different fire protection systems, different transformers, and different sizes of cables, and different application, a different energy output, and different throughput bandwidth requirements for the networks. Everything is different, although it looks the same from the project name spawn, from the project type point of view, but the content of the projects can be completely different. That's why we come in to look at your systems components by components, area by area, to identify any anomalies based on our past experience and the knowledge within renewable energy. We work closely with equipment vendors and OEMs, such as inverters manufacturers, battery manufacturers, and transformer manufacturers, to understand their capability. And we understand their equipment's capability and the functionality. So when it comes to the SCADA design, we will automatically know, and we'll be able to produce a solution efficiently for you that will mitigate your risks later on. So you will have fewer surprises, more certainty, and better operational outcomes. Overall, this blind spot is preventable. And in the future episodes, I will unpack further where this risk shows up next. Thank you for your listening, and thank you for watching. If you like today's talk and the video, please thumbs up, likes, and subscribe. And I'll see you in our next episodes.